Riverside, and I'll let Brian Roth talk a little bit about engineering. He's looking shocked, but I don't know the numbers for engineers.
So I'll speak briefly for mechanical engineers, and then I'll pass the mic on to Kurt Nelson to speak about the computer and electrical side. We have, I think, about 120 mechanical engineering students, and a good representation of those here tonight. I think we have 4 or so mechanical engineering students here, and I'll pass the mic to Kurt.
The School of Engineering has about 250 total majors, of which probably 50 are electrical and 40 are computer engineers. And then Brian mentioned 120 mechanicals, and the rest are civils.
Cool.
Anything else for us?
That's great. And incidentally, I already started recording. I forgot earlier. So on our side, so let me just go around here. So I'm Bernard Pham, alum Walla Walla in the mid 1800s. Electrical engineering. I'm a program manager here in office. Brian, you want to go around?
Brian Xavier. I graduated from Walla Walla in 1990 with a mechanical engineering degree. I hated computer science at the time, and I've been doing that ever since. And so I've been here for almost 8 years at Microsoft. And I'll say a bit more about my roles when I get into my talk, so I'll just leave it at that right now.
I'm Eric Smith. I went to WW, but not Walla Walla. It was Western Washington University, and then later UW. And I'm just a software engineer in the Windows group.
Yeah, very modest.
I'm Adam Barr. I didn't go to WWU, and I'm an engineering manager in Office. I used to work with Bernard until about 2 weeks ago when I switched jobs.
I'm Josh Grant. I'm a Walla Walla alum from 2011. Now I work in mechanical engineering for my manager, Dave Wood.
Hi, I'm one of the managers of the awesome Microsoft Surface product.
Oh, where is it?
Got to get a plug in there.
Yeah, there you go.
There you go.
Yeah, camera right here.
You should have one for every student at the school. I think WWU ought to purchase them for their students. So.
Yep, great. So with that, let's get into the talk. So the agenda we have is I'm going to take a few minutes and talk about our internship program, and then Brian is going to spend some time talking about how you might want to write your resumes and think about your interviewing skills. Adam will talk about software engineering. Israel, who is on his way, is going to talk about program management. And Peter is on his, David is going to talk about mechanical engineering. Then Peter is going to talk about electrical. Okay, let's get going. Can you guys see the slides, David?
Yes, we can see the slides, but there is a picture hovering over your screen that's blocking some of them.
Okay. All right.
Yep.
Better?
Exactly. Better. Thank you.
All right. What is the? How's this?
There you go.
Good.
Yes. Thank you.
All right. So Microsoft has an awesome internship program called Microsoft Explorer. It is actually geared to give freshmen and sophomore an opportunity to experience in a 12-week cycle in the summer, rotating through 4 weeks of software engineering, 4 weeks of test, 4 weeks of program management, and give them a feel of what the different disciplines is early in their college life, and then hopefully will help them, decide to change major or to take, the appropriate classes. It is it's a small program. It's very competitive. It actually selects from truly students from around the world. I happen to be one of the folks that interview students in that program. The students that come are pretty impressive, like all of you guys, I know, and it is interesting. So unfortunately, this summer's interns have all been selected. So this is how it works. Every fall, so coming this fall, we will start on-campus interviews for the a few privileged schools where Microsoft dedicate recruiters to go to the campuses to recruit, like Adams School, like the Ivies, and the big name schools. They will go there and do on-campus recruiting, and they will interview you, and then they will select to see if you should come on campus and do a real round of interviewing. So I interview on folks that come on campus. So we'll talk more about what is necessary. So I would suggest that for the summer of 2006, in late August, you guys start, putting your ear to the ground, and I will show you how to apply and get onto the list. There's also, Microsoft also offers scholarships, and I'll give you links to all this, okay? So this is what I was talking about. One thing I want to highlight is, I don't know how this will work for your programs at college. Most of the time in freshman and sophomore, I was pretty clueless, or, why would you think of want to apply for an internship for Microsoft? Now, don't be misled by this. Somewhere here, it says that, it's the next one, requirements, okay? It says the requirement is you need to be a freshman or sophomore, and you need to have completed a class in Introduction to Computer Science and Calculus. From experience, I tell you that's not enough. I want to say it's a lie, but it's not enough. I have seen candidates that come in and interview, and the interviewers, especially the software engineers like Eric and Adam, but not them, they're merciless. They ask very difficult questions. And so I would suggest, my experience is at least take the class in data structures, know one programming language. So one programming language, data structures, calculus, I really don't know how important that is. Anything on that?
Well, the only thing I'd say is that you don't have to learn in class.
Yeah.
There's nothing magic about it, especially with software. You have to take a class in there. You can study on your own. You can work on websites, work on mobile apps, or whatever. So it's a pretty low barrier to entry in learning how to program. But it's true. Interviewers expect people who can write code that works. So you either pick it up on your own in high school, on your own in college, or you take classes. But if you've just learned the basics of programming, you're very unlikely to pass a Microsoft intern interview.
Yeah, and to give you an idea of the spread, so we have a team of three: a software engineer, a program manager, and a tester. And we interview them, all three, round robin, and we'll come back and talk about it. So we will either say hire or no hire, but we also say for the outstanding candidate, let's hire this person as a software developer right away. So so that track is also possible. Okay, so how to apply? These links. So David, I already sent this deck to you. You can share this around, and I have already preloaded something.
By the way, I got the slides. Thank you. I already got them.
Okay, that's great. I want to. Where are my links? They're not here. So I'm going to waste time doing this. Too bad. Wait. Is this going to work? Okay, it's going to work. So I'm going to click to and bring some of the links up so that you can see. And right now, I'm going to give you the actual links here. So the key point I'm going to pass to you on my last slide is this. Gone are the days, right? Eric and And when we get news and notifications through posters or mail, now even Microsoft notify and stay in touch through social media. So we have job blogs, we have Facebook, Twitter, and LinkedIn. I strongly suggest that you guys go to the Microsoft Internship program, log in with an account, and then you can then get on of these links and then just get social. Okay, so I'll show you what this is. All right, I should kill scorecard. Sorry, this is my work. I shouldn't show you. All right, so this link basically takes you to the university career site. You come here and you hit apply, and I think it asks you to log in or create an account. So if you don't have an account, create it. And it will basically, from then on, allow you to be a human being when you come to any of the social media. LinkedIn. And here is where, Microsoft will announce news. Other people who look for jobs like you guys, you get it, it's social media. And you guys will be able to find your way around it better than I will. And I'm pretty much done here. Any questions?
Anybody have any questions? You can speak to the microphone if you want. Yeah, we do have questions.
You mentioned the Explore program for freshmen and sophomores. Are you going to talk about, do you have internships for like graduate students or students that are in later years in college?
So for the junior students and even seniors, I think you would apply through this link. Come here and hit apply. Actually, let's go do this. When you hit apply, so you would actually come here and search for either full-time jobs or internship. So I don't want to take the time to, walk you through this. I think a little bit of this is interesting. You would come here and say job families, deselect all, and then pick software engineering, whatever. So does that answer your question? So let me be more crisp. I think if you're a senior, you got to look for a real job. Graduate student, there's no internship. It is freshman, sophomore, junior. Is that okay?
That's clear. Thank you.
But the idea is that the reason we do Explore with juniors and freshmen and sophomores is so they can try out the different disciplines, and then the expectation is generally they'll come back after their junior year as a full-time intern, as an intern only in one of the jobs. So having explored them in the previous year, they'll then know what they want to do. It's for people who are undecided about what particular aspect they want to pursue.
Okay.
One more question from me, Bernard. You mentioned that, you recruit worldwide, and it's highly competitive. What can our students do to stand out in their application process?
Well, I have to think hard whether I should say this. I've been in touch with the regional recruiter. She says I can email her outstanding candidates and she'll put it through. So you can email to me. Okay?
Okay, we have one more question.
Go ahead.
How much hiring do you guys do outside of your regular fall hiring period? Full-time stuff.
Oh, full-time? A lot. Right, Dave? Right, Brian?
How much we do outside of the regular fall?
Can you speak louder, please, that question?
Yeah, sorry, do you need me to repeat it?
Yeah.
How much hiring do you guys do for full-time jobs outside of fall?
Oh, all the time, year-round.
We do a big college push in the fall, but we hire people not from college or from college anytime they show up.
More questions? Okay.
Okay, I think we're good.
All right, the next segment. Brian, no, you can speak through that.
Yeah, I need to tap to go along here. Tap on the buttons. Just switch places. All right, so I introduced myself earlier, but I'll just go again. I'm Brian Xavier. I actually went to Walla Walla 88 to 90, and graduated with a mechanical engineering degree. I didn't want to get into software at the time, but that's exactly where I ended up. And so for the last many years, I've been doing software. But right now, I'm actually looking for another job, looking for a job as a program manager. So I've been working on resumes. I've been interviewing and doing this kind of thing. And so I think I can share some tips with you as I go on about, first of all, writing your resume.
Hey, Brian, can I stop you there? Can you elaborate what looking for another job means?
For me?
No, I mean, I don't think they know that you're looking for another job within Microsoft.
Oh, yeah.
Okay.
So I'm not leaving Microsoft.
So you were not putting in your notice, right?
Right.
Maybe you can tell them, it's actually pretty convenient and nice and, yeah.
Yeah. Actually, so, there are literally hundreds of jobs out there right now in the program management field where I'm looking to go to, and all kinds of different areas. So I have a huge field to pick from, and of course I want to find something that matches what I like or what I know, and I'll talk about that as well during the resume writing and interviewing skills.
And you can go talk to the hiring manager directly.
I certainly can from here, yes. I've done plenty of that.
So people like us internally, when we switch, we have a huge edge over you guys from the outside. Just want to let you know.
For sure. Okay. Looks like the animations didn't transfer properly on the copy. Okay, so this is, the font's terribly small here. It was much bigger in my original deck. I'm going to cover four areas on the writing your resumes. And if you folks in here have great experience doing that as well, you can chip in. I mean to be brief here. There's a whole lot of other things about writing a resume that you should know, and you can always go to the bookstore or library and find a good book on a current book on resumes. But I'll tell you a couple things here. So you are looking for a computer science job, most likely, or something technical. And so your toolkit, the skills you have in computer science in the technical field, need to be front and center on your resume. By that I mean they're up at the top. You're coming into a job here where you don't have a lot of experience behind you. And as a hiring manager, and I've hired before plenty here at Microsoft, I look at the resume and I'll say for example, I want someone with good C# experience. And I look at the resume, and if they don't have C# on there, I just toss it and I keep on going. I'm looking for C#. I'm looking for some experience that says they know C#. So if you have your programming skills, put them up in the front. I'll mention here your languages that you know, Java, C#, whatever it is, put it up there. Your development environment, if you know Visual Studio, if you've worked with some Java tools or IDEs, put them on your resume. Methodologies, I'm talking here things like Scrum or Agile or Lean, whatever your kind of development experience you may have. If you have it, put it on your resume. As a student, you may not have a whole lot of job experience. If you have some particular computer science classes or technical classes that you think are relevant, put them up there as well on your resume. A lot of times you may not have the job to say you've done it, but you had a class and done some homework and you've learned a couple things, and you can talk about what you know as well from that. On tailoring the resume for the job, this is important. You need to know the job that you're applying for. It does not help you very much at all to just send your resume out blindly to a bunch of different jobs. And when I say that you should know the job, what I also am implying here is that you should have a resume for each job that you're applying for, because you need to tailor that resume to say you know the requirements of this job, and here are why you are applying to the job. You understand them, and you are describing the skills you have that match the job. Now, you may say that, well, I can't describe that very well for myself. I haven't yet had my first job. But if you look at the job looking for someone who is eager and passionate, and you'll see language like this in the job descriptions. Well, find ways that you can describe that about yourself in your past past experience, whatever it might be, even if it's working at a mom and pop store or in the computer lab. You've had some kind of exposure to what it means to, take the boss's to-do list and go work on it. How do you do that? Make sure you understand the words to use to tell the person looking at your resume you have experience in these areas. Stating your objectives clearly. One thing you want to show up front on the resume is that you want this job. And I say here, you want the job. You're talking about the very job you're applying for on that resume. You know what it is, and you say, my goal is to work at this job, to do this thing in this particular company. You need to be able to say that. If you can't say it, if you don't want to say it on your resume in those kind of words, make sure your resume is saying that, though, with the way it's presented, that you know the job and you're applying for this great job. I'm saying here, be succinct. In that objective, you don't want to have, multi-sentence paragraph describing why you want to take this job. You need to be very, very clear, one or two sentences at the most, why you want this job. Operational details about your resume. There are plenty of templates, ideas to start from on what your resume should look like. If you're looking for a technical job, don't go find a marketing resume kind of style. So what I mean by that is you can go to the library, you can go online. There are all kinds of templates to help you get started. They're very useful. They basically are showing you, fill in the blanks pretty much for it. Your objective goes here. Here's how to lay out your job experience. Here's how to lay out what your tool set is that you have with you. Use that to get started. Finally, spell check. Very, very important. But don't forget that it is the same as it, and it won't catch it. So have somebody like IT apostrophe S and ITS. Your spell checker might say it's fine, but it's still wrong. So have someone look over your resume, give you feedback on how it reads. Ask them whether it conveys your experience that you have and your passion for the job. Hopefully that's all on your resume. Anything from anybody here in the room you want to add to that? Any key areas?
It is important to remember your audience that is doing the hiring is older than you are. We're used to looking at things in paper. We're used to being beaten for the apostrophe in the wrong place. It's very important to consider that. And when we're looking at resumes, that's an easy item. When you got 20 resumes, you got to knock it down to 2 or 3. Those are easy things to get you kicked out of the list. Those are not reasons you want to be kicked out of the list because they're in your control. You have the power to totally fix that. He's right. Have someone review it. It's not a long task to have that done, but it can make a big difference on if you end up on the floor or you get a callback.
Yeah. So I think I'd say, because I look at high school students' resumes sometimes, if your email address is some joke about, whatever that doesn't really make you sound particularly professional, then just get a second email address that's your name with a number at the end or something. Because it's sort of silly, but it just makes you look like you're not taking the job that seriously.
Yeah. I want to add something, kind of like what David said. You want to make your resume pop, okay? And nowadays, people have so much to read. Think about this is how I would look at it. If you have 3 lines to say everything you want to say to convince the person, what would that be? If you can manage everything in 3 lines, challenge yourself to do 2, then to do 1. And I think that really helps because, like David said, he's an engineering manager. He has to go through a pile of them. And that is after 200 didn't make it to your desk, right? So your resume can be part of 500 or thousands. Literally, I was told many years ago that Microsoft gets 5,000 resumes a day. That was 10 years ago. So I don't know what it is now. So keep that in context.
I think one more thing that I would add is also be cautious of what you put in your resume. And the reason I tell you this is because my son ended up, He's a sophomore now in college. He went to a fair. Google was there and a lot of other people, and he had worked on the hackathon at Walla Walla, done these other things, understand HTML, JavaScript, CSS. First thing the guy says is like, "Oh, great. So how do I get an element from the DOM?" And he went like, I don't know. So be ready to talk to everything that you have in your resume. And if there's a class that you are highlighting, go over the notes. Remember, talk to somebody who just recently took the class and sort of remind yourself what was it all about, because your credibility drops huge the moment that one line on that resume you can't be backed.
So preparation.
Preparation is huge.
That's brutal.
Yeah. Actually happened to you?
Yeah.
So I'll add one more thing about the resume. You will find when you go online to apply for a job, even here at Microsoft, I find this from my own experience here, from my own, applying for jobs. It asks you to enter a resume, to find the file on your drive and upload it. And now your beautifully formatted resume turns into ASCII, and that's all it is. And so you'll see it the way you'll see online what it looks like in this, unembellished format. And I would say go into that format if you can and make it look a bit cleaner. Add the paragraphs that are now missing. The bullets are all gone. More bullets. So as you work on your template and your resume, it doesn't hurt to take it out of Word or whatever program you're working on, take it into Notepad and paste it in there and see how it looks. And if it just falls apart, it might happen the same way when you submit it to many sites. So just keep that in mind. Your resume should look very good because you will be mailing it out to people, but you'll also be applying online, and you need to know how it'll show up on a site that just pulls out the text. All right. Any questions from you guys about writing resumes? We can do some more questions at the end as well, so don't have to have them all now, but if you have any, let me know.
They may have a question?
Go ahead.
All right. I think we're clear on this end.
Okay. So for doing the interview, I'll cover, I think, 4 areas here as well. What the interview is for, telling the interviewer how you think, and I'll get into that detail in a bit. Ask for clarification and be clear. Actually, just 3 areas here, so good. So, what's the interview for? It's really to find out what you know, to find out your limits, and also to see if you fit the team. So you may come in thinking, hey, I got all the technical skills in the world exactly to match this job. And you can prove it in the interview. But if the team is looking for someone who's a great team player, fits in, very outgoing, kind of a cheerleader for the team kind of person, and that's not you, then you probably don't fit the team or what they're looking for. So again, the job description will tell you what they're looking for, and if you think you fit, that's one thing they're going to look for in the interview. They're going to ask you tough questions, and hopefully you do know the answers. And then at some point, they may ask you a question where you don't know the answer. And that's part of what the interview is for. You probably don't want a job where you cannot do what they're asking you to do. So if they get into an area where you can't answer the questions, I'll cover that in a bit later as well, but don't try fake it, telling you don't know something. So not too much there. I mean, the interview really is like introduction. It's telling you about the company. They're gonna try and sell you on the job. In many cases, they want you to choose this company to come work for them, but they also want to find out about you and whether you are cut out for this job. Telling the interviewer how you think. I found this many times when I'm interviewing and the person answers the question, goes to the whiteboard, for example, and starts writing out the code, and they say, there's the answer. I can't tell in that particular case whether they have memorized something. I can't tell exactly how they think. And so as you're working out the problems, the interviewer's going to ask you, solve some problem for me. I recommend very highly that as you think about the problem, that you try to verbalize it. Describe what you're doing. you may say something like in your mind, well, I know this requires a recursive, this is a good recursive solution. So describe what you're thinking as you're doing it. You may even say, well, I don't know this area very well, but I think this is a better solution. But since I don't know it, I'm going to choose another one that I think is a bit easier. Now, if you hadn't said that out loud, the interviewer doesn't realize that you know a little bit about the harder area, but the easier one, you know more about it. They just think you just don't know anything about the other side. So talk through your thinking. And I recommend that you practice this with some of your friends. Have someone ask you a problem question, and then talk through your thinking as you work it out. Breaking the problem into pieces, someone's going to ask you some pretty tough programming question. You may find that there are parts of it that you know quite well and parts of it that you don't. Well, if you try to solve the whole thing in one piece, you might find that you just fail. So break it apart, attack the parts that you understand, and elaborate on them. Be clear about the parts that aren't as easy for you to solve. This is kind of how you do your homework for whatever class you're in. You want to break the problems down into smaller and smaller bits until you can solve each small piece. So this helps you in the interview kind of manage the pace of the question and how you're answering it. Last one here is pretty important. When you get here to Microsoft, you'll see that there's all kinds of people from all over the world here. And there's oftentimes when I'm interviewing people who don't speak English as a first language. And it's very important that either you, if you are the one who doesn't speak it as a first language, or you're talking to someone who doesn't speak as a first language, that you are clear on what they're saying to you and what you're saying to them. So if you hear something and you didn't quite understand what they said, and by the way, this is not just about English as a first language. This could be a strong accent. It could be just a muffled word. You didn't quite hear it. Don't guess at what they said. Try, go back and say, now, I heard you said this. Is this what you mean? Make sure you're clear on the question before you start answering it. Speak clearly in your own answer. Look at the interviewer, speak to the interviewer, and look for understanding in that person's eyes. Like if you're talking to them and they don't appear to get it, try again. Try to make sure the person is understanding what you're saying. It could be that they don't understand English as well, or perhaps they're not understanding your English as very well. But speak clearly and look for understanding. And then finally here, if you're asked the question and you do not know the answer, it's way better to say you don't know. Maybe you can describe somehow that it's similar to something else, and you can show some, how you might attack a problem in the case of not knowing it. But don't get yourself, don't embarrass yourself by trying to solve something that you just can't answer, and then you're all wrong, and it looks pretty good. It doesn't look really good for you.
Yeah, on that topic, to reiterate what you said there, if you don't know something, say that you don't know it, but then tell the interviewer what you do know about that subject. Because you might just not know the final 25%, but you do know the first 75%, and that's all the interview wants to see.
Yeah.
So
and that's part of
what you do know as well.
That's part of that thinking out loud. So you might say in your mind, oh, I know the whole thing up to some point. Well, describe that. Talk about that. Describe where your limits are. And that tells the interviewer, this person can solve a problem. They can think through the steps. They can break it apart, and they can solve things that way. Any other things from the room here?
Yeah, one thing I find helpful is, so it's very natural coming from a school environment to think that there is a right answer when you presented an interview question. The truth is there's no right answer. You want to be of the mindset that you are there. They are just. You want to understand that they are just there to help to see how you do problem solving, how you scope the problem, how you say you would how you do what you say you're going to do, and then recognize what you don't know how to do. So don't be afraid to just speak out your thoughts. So the whole idea of not of understanding that there's no right answer really takes a lot of pressure off you. At least it did of me.
And on that same subject, something that I think helps me take a little pressure off is not seeing the interview necessarily as an interrogation, but use the interview as a time. You kind of mentioned this as getting to see, but I would really look at your managers and get to know them and see what their leadership style is, and make sure that they're the type of person that you're going to want to be working for. If they're not someone that's going to really help you develop your career and kind of push you, then maybe that's not the right fit for you. But that's a very important part of your job, is who is going to be above you, who's going to be your boss, and are they going to be working, helping you to push you to whatever your career goal is. So.
I think one just last thing is to keep in mind is that even there's three key pieces I think that I've heard many people across Microsoft say that's important when you're interviewing too, which are, even if you know the answer, even if you know the problem, right, even if you understand it and they just told you the problem, you understand it, always ask questions. It doesn't seem, even if it seems silly, like a friend of mine was telling me, you're going to do a flood fill algorithm. Okay, great. So how do I determine how am I going to flood fill it? Do I need to actually go ahead and look diagonally, horizontally? Do I go ahead and look at vertically? You know, like what are the different choices? Turns out that when he was saying that, diagonally was not something he wanted me to solve. Great! I just solved myself a hard problem, right? I know I'm going to do it horizontally and vertically. So little things like that when you ask is important. The other one is to go ahead and, for the problem that you think you're going to be solved, start with a unit test. Give an example. Okay, this is what I understand. If I was given this set of data, this is what the outcome you want me to do is. So walk through that, and then after that, don't start writing the algorithm on the board right away, which goes back to what you were saying earlier, which talk through your algorithm. Help them understand that this is what you're about to design. And that way, in the process of doing that, they might even give you hints. Because in this case, when I was working with my buddy, he said, oh, yeah, there's 2 methods that I forgot to give you. Oh, great. So he gave me the 2 methods. Okay, that I know I can use those, right? But unless I would have started, if I would have just gone to the board and start drawing it right away, it would have actually missed that. So I think that if you follow some of those, then at least you'll give yourself some time to think through it. You'll be sharing what you want to say ahead of time before you get yourself in a rat hole coding. And it just kind of gives you, at least, if you don't have a chance to finish the algorithm, they'll understand that at least the algorithm that you explained and you had in your mind that you were going to write was the correct one. Yeah. So it gives you some slack, basically.
Yeah, I want to round it off with the context of, if it sounds like we're making this interview thing a big deal, it is because it is. Because we all been through it. It's kind of torturous. And to give you an idea, well, just my example, when I interviewed here, I started at 9, I didn't leave till 7 p.m. And it's an hour, a person every hour. And it is can be very tiring. So that's the context to which what Brian is talking about. Are we good?
Yeah. Any questions from your side?
So this is really rich, detailed information on how to pass the interview. We do have one question here.
Go ahead.
Sorry if you're going to say something, David. My question is, well, specifically for software, like for practicing for the technical side of things, like a lot of the interview questions that at least I see online are things that you aren't really going to encounter in class. It's like problem solving on the fly, kind of hard to practice. I've heard projectoiler.net is something good. Do you have any other things you suggest for learning how to practice for the technical interview?
I think that, if you go to those sites and just say, insert a linked list, well, that's the main question, but, I just practice on those. I think that, I've talked to people, I say, can you write a sort algorithm? And they're like, yeah, I can write a sort algorithm. And then I say, well, can you actually write one now? And it turns out they can't. They just think they can. So I think just practicing with some of the standard questions actually works. It gets your brain in the mood of solving those kinds of problems. And also, there's studies that show that if you think you can solve a problem, it actually relaxes your brain and makes you more likely to actually solve it. So you need to go into the interview with the attitude that you can solve the technical problem, whatever it is. And having solved some as a warm-up, I think gives you more confidence that you can. You can actually essentially trick yourself into performing better in the interview. So I think the questions I see, honestly, in feedback are not particularly complicated, especially for a freshman interview for an Explorer job or something. It's the stuff that's out there on the internet about questions that technical companies ask. It's just a lot of people cannot answer them in half an hour on a whiteboard.
I actually have seen some very difficult ones, as even for the Explorer, just to give you the other extreme. I mean, the one experience I had is I was the third interviewer for this particular student. 5 minutes into my conversation, she started crying. I was shocked. So it turned out that she was given a very difficult, what do you call, coding question in his first interview, and that kind of, made her feel really bad. So again, it's kind of like it's all about nerve. Anyway, I think we can move on.
Yep, sounds good.
I'm going to talk about software engineering, and it's really, I think that's one word on every slide. Well, or 2 words maybe. It's basically things that you don't really learn in school a lot. So somebody asked earlier how to make students differentiate themselves. It's having experience in some of these areas does tend to differentiate you, because a lot of CS majors don't learn this stuff. So if you want to be my
slide monkey, yeah.
First one is unit tests. I think this is actually becoming more prevalent in university curriculums, but basically write unit tests. If you don't know what unit tests are, then learn what they are and write them. Because again, if you can come in and talk, well, first of all, a lot of coding interviews end up, or even as someone suggests, you start with a unit test discussion. How would you test this? So it's a good thing to think about, but also just having some experience will be quite useful as something to talk about in your interview. Next one. And then automated tests. So unit tests are automated also. This is basically more a full-scale end-to-end test. So Microsoft recently combined the dev and test disciplines, so now everybody's a software engineer. So you'll be expected to do automated testing as well as writing code. So again, it's not something that a lot of schools focus on. So if you have experience and you can talk intelligently about it, it will set you apart during an interview, especially what trade-offs you made and why you tested this way and what went well and what went badly, that sort of thing. Bing. Legacy code. So this is something that most school projects start with from nothing, and you write code to solve some problem. And almost no project at Microsoft starts like that. Excel, I think, has source code from like 1987 buried in there somewhere. So, again, having experience confronting a giant pile of code and actually making changes is unusual for a college student. It is what you'll probably be doing at Microsoft, so it's good experience to have. And again, it's something you can talk about that the interviewer will be interested in.
And actually, in real life, when a new hire starts, don't you typically give them bugs to fix?
Yeah, I mean, not as a punishment or anything. It's a good way to learn the code.
That's legacy code.
Right. But yeah, it's all legacy code. Code reviews, again, I don't know if you guys do this, but at Microsoft you will be doing code reviews. People will be reviewing your code, which can be a little
uncomfortable.
Uncomfortable for people if they haven't done it. And you'll also be expected to comment on other people's codes. So it's useful for that. It's actually good practice for coding questions, I think, because you're essentially doing what the interviewer does. You got a little bit of code, trying to figure out what it does. And also, you get feedback from others, so it makes you better. And you're usually working in a fairly big team at Microsoft, so it's good to get a lot of feedback from different people.
What's big? Size.
A lot of different people. Well, you'll probably have 5 to 10 people that your code intersects with their code on a daily basis, if you know what I mean.
And if you integrate with other components around the Office or even Windows, and if you use their code,
oh yeah, I mean there's a lot more than that.
Pass them to code review, right?
Right. Yes. You also wind up getting code reviews from strangers, and again, they have their opinions on what's good and what's bad. So it's just good practice giving code reviews and receiving code review feedback for a bunch of reasons. So security is another one. So we have to write secure code here. So there's a particular process around reviewing your design for being secure. There's certain tools we run to check for banned APIs. So again, this is something that if you have done anything like this, if you're aware of security, it's quite helpful as experience. And then there's also the actual field of security, which is dealing with encryption and that sort of stuff, which if you know that, then you'll be guaranteed employment for the next 100 years. So that's a great area to study. But just in general, everybody has to write secure code.
So what is banned APIs?
Well, we can't call Sterling anymore, if you're familiar with the C standard library function called Sterlen. It's just not allowed. There's tools that scan for it because it's unsafe. Again, I won't tell you why Sterlen's unsafe. You should be able to figure out why Sterlen is unsafe. You may get asked in an interview why Sterlen is unsafe.
So basically, for a big company like Microsoft, there are software and coding standards, and there are some watchdogs. Adam was one of them that set standards, and so there are banned APIs. Right? You want to talk about security? Are you thinking SWI reviews and stuff?
Yeah, I mean, it's also if you're doing anything with cryptography or storing data in the cloud, transmitting data over a network, there's all kinds of opportunities for people to steal data. That Microsoft has been entrusted with by our users. So if you do anything like that, you'll go through a security review where you'll have to explain what you're doing to encrypt your traffic or how you're guarding the data that's stored in the cloud, that sort of thing. You don't have to know all those details, because some of those are Microsoft specific, but just having a general awareness of security and sort of what's involved in securing data is quite useful. Serviceabilities, this is basically, again, because we have lots of customers, we have to update our code, we have to do patching, so issue updates on the fly. We have to make sure that if we have multiple pieces of code working together, they work together even if the versions aren't all matched, because we get that situation in customers' machines. And then for services, we have to deploy stuff to running services. So again, it's another area that people in college don't tend to have a lot of experience with. You might write a piece of code that just runs once, and then the semester's over and you throw it away, or you write a web service that runs on one server that you update once and then demo it. And the real world's a lot more complicated than that. And we got localizability. This is the ability to both to make software translatable into other languages, but also work in things like countries where the text runs right to left instead of left to right, where the decimal separator is not a period, it's something else, where the currency symbol is different, stuff like that. And again, and of course, all the actual text displayed has to be translated. And again, it's not something people typically worry about writing school assignments. And then telemetry is a big focus. This is gathering data from customers, both about usage and more importantly about debugging stuff. So if you can imagine, for a lot of the software that we write, the errors don't happen in the lab. They only happen on customers' machines. So you have to log enough data about what's going on when something crashes to figure out what went wrong using only that data. You can't just debug it. You can't get to the data, or it happens with some file that the customer doesn't want us to see because it's got social security numbers in it or something, or whatever. They just don't want us to see it. So it's another thing you could work on. Imagine, can I write my software so I write the log file or something, and every time it crashes, I can actually figure out what happened from the log file. And also something unusual that would set you apart in an interview, and something you could discuss about, well, I did my telemetry, and then I realized I didn't handle this case, and so I did this, and blah, blah, blah. So please hire me. Oh, yeah, no, there's more. Maintainability. This is about, basically, don't be too clever when you're writing code. You probably won't be the only person who looks at it, working at a company like Microsoft. So make your variable names clear, make your logic clear, good comments, all that sort of stuff. Good variable names. And finally, you will be asked to estimate how long your software is going to take. So college projects are nice because, you have a 12-week semester. Well, you're given a project that takes about 12 weeks to write. Somebody's already figured out what's expected. But when you're working in Microsoft, of course, you're almost by definition the first person solving the problem you're being asked to solve. So you'll be asked to estimate how long it's going to take. And it's not that you're signing in blood it will take that long, but it's another good skill to work on. I think you could imagine any project you work on. Before you start, just think about how long do I think this is going to take, and then halfway through, think how long is it going to take to complete, and then when you're done, look back at how long it took and figure out if your estimation was high or low, and then what you could do to become a better estimator. As a final note, despite all the stuff you have to worry about in process, you are given responsibilities, somewhat surprising, I think, for a lot of college hires, that, it's your code and basically you're responsible for it. You can easily cause a security breach, Office to crash all the time by making mistakes, and we do have millions of customers, so you're given the responsibility, although there are processes in place to worry about all the stuff I talked about. But we do actually basically trust everybody we hire. We had an intern who's just finishing up, who's wrote some feature that will probably ship to whatever, lots and lots of people in a couple months, and that was her work all along. So that's part of the reason we try to hire good people, because we put a lot of responsibility on them.
So Eric, do you have anything you want to add?
As you were going through that, I was trying to decide. I thought that was a pretty good list, actually. So, well, nothing comes to mind.
Okay. If you have any questions, like I said, a lot of this is just to spur questions. If you're interested in more details or what I was talking about, please follow up with questions.
So David, questions from the audience? Are they there? Uh-oh. Hey, David.
We've been talking to...
Yeah, I could start over.
This sort of goes back to something that you were talking about earlier, about making sure that your resume looks very clean, very nice. The language is good and the grammar and punctuation is all proper. The punctuation in particular, I see the value in it definitely, but have any of you ever actually spell checked a resume to see if somebody typed HTE instead of THE?
I say no.
I think this he might be talking about something else.
Asking that.
What can David? Can you guys?
I stepped out for a few minutes.
Oh, okay, so we didn't get that question.
Oh, you didn't? Can you hear me?
Yes. No, yeah, we can hear you, but can you repeat the question again?
You were saying that we need to make sure that our resume is, the grammar is good and the punctuation and spelling are all absolutely pristine. But you said that you handle hundreds, thousands of resumes. I'm guessing that you don't spell check the majority of them. So if Microsoft doesn't understand that I've made it.
Did you guys get an opportunity to hear the last presentation we just did on the software development?
Yes.
Okay, cool. So you're just going back to a previous question on a previous topic?
So the short answer is no.
But let me add, when I hire, oftentimes I'm the one pulling the resumes, or they're being given to me, and I'm looking at the resumes on paper, deciding who I'm going to bring in. And I do find spelling mistakes on there. And they mean something. They say this person is not very careful. They haven't thought very well about what they're doing. So I wouldn't say that I have turned down necessarily because of the spelling mistake, but it does create an initial impression. It actually takes away from the initial impression.
I don't think Microsoft runs a bulk spell checker on resumes.
Yeah,
not at all.
Throws out the ones, but yeah, I've seen typos and it does look very sloppy.
Yeah, don't worry about it. There are a lot of other things that was mentioned tonight that you should worry about. So can we move on? Okay.
Are there any questions on the sort of software engineering side of the house?
Yeah, good. So did you all hear the presentation for the software engineering? Yes. Okay, great. No question. Adam, you are awesome. Okay, now we'll move on to the art of programming. Yeah?
I would suggest maybe describing what a typical project time frame is, what the cycle is.
It's agile now, right?
Well, yeah, the question is what the cycle is for projects. I mean, it varies widely, but Microsoft is now shipping most of our products monthly or sooner, so it's we have things that take years and things that take a week or something. So it really varies a lot. Even when we were shipping every 2 or 3 years, we still had things that took less time. But so we will ship it. We will ship things quickly, but then we'll take some big reworking of something and go off and work on it for a year or two, and then bring it back into the product.
Okay, Israel, can you, since you were not here when we did the intro, can you intro yourself?
So I'm Israel Hilario. I am a lead program manager in the IE team, Internet Explorer. That's the browser, in case
the other browser.
Many of you, I'm sure, use Chrome. It's one of our biggest competitors, and some Firefox. But anyways, my team at Microsoft is responsible for managing all of the networking, crypto, all of the media and storage that you actually have built into the browser today. So all of those different stacks, we have a set of program managers that report to me that each one of them has their own specific area, and then we work with our development counterparts and our quality developers who actually help us take measurements, which actually brings us to this slide on how really the different roles that you actually see at Microsoft. And a lot of these pictures are constantly being renamed. They're constantly changing in terms of responsibilities. But basically you have sort of three disciplines. And this kind of varies more so by different organizations within Microsoft. So you have like the applications, this is Application Systems Group. Is that ASG? Yeah. Is that what system? Yeah. Is it systems? And then you have
software.
Application Software Group. You have the Operating Systems Group, OSG, which is the one that I actually belong to, because the browser is part of the operating system. But within each one of them, there's sort of three distinct things that happen. And what you find is that you have developers who end up writing the features and who bug fix those features. You have a set of program managers who are responsible, as we'll go into more detail here, for sort of directing what is it that needs to be built. And this is at the concept level. And then you have a set of developer quality individuals or software engineers in quality who end up trying to gather information in the case of OSG about measurements that are going to be used for providing some insights into how our customers are using our products. And they're also responsible for understanding the end-to-end scenarios and how all of those different components that are being built throughout the operating system or throughout the different application are going to come together to actually solve a solution. And they're going to verify that that solution is solvable, right, based on the hypothesis that we're going to be putting forward. So when you look at the program manager job, really there's sort of four categories. And I'll tell you which one of these is somewhat being phased out and how it is being proposed in its place. And normally the main goal of a program manager is really to tell the story, is to draw the box and set the direction, right? And by this box is really the system. What is the system going to do? And what is the problem that we want to solve? And they're going to be telling the story. And as part of that, there is some high-level design that needs to be defined. In some cases, the story needs to be made up of storage. It needs to be made up of communications, services, different pieces that in an aggregate might be owned by your team. It actually may be part of another team. I need to start defining those high-level pieces so that you can start identifying the different responsibilities that each one of those components will play in your overall solution. Now, up to now, program management has also been very hands-on into project managing the execution of the actual feature that is being released. This is one of the areas in which development, now the software engineering aspect of Microsoft, is going to be taking more ownership now. And what program managers are going to be asked to do is work more on the outward-facing aspects of designing your feature. So that would mean, what are the customers that are going to be using this? What are the problems that need to be solved? How is it that it's going to be perceived by the market that you are going to be developing this for, right? So this is one of the phases in number 3 that is being sort of morphing into something else. And really number 4 is sort of keeping the vision flame burning. And what really that means is that you need to be the cheerleader, call it, the guy that's or the gal that's going to be there going and encouraging and making sure that you're motivating your team, that they still understand where is it that we're going. That light at the end of the tunnel is not a train, is really a light, and we're going in the right direction, right? So this is one of those that you normally have to keep going, because as the project drags and some of the deadlines tend to stretch at times, right, it could be a little confusing on why we're doing this.
Actually, I want to add that there's tendency for projects to just go astray, and there are some developers who like to do their own thing. So we have to keep the end product reminded.
There you go. That's a great way of saying it. And one of the things that actually I wanted to start with is also with the whole understanding that when you look at software and developing a piece of software, it's not just a science, it's also an art. And what that really means is that there's parts of it that are well understood that you can solve with algorithms, and there's other parts of it that are sort of more intuitive, that are things that you kind of have to extrapolate, hypothesize, and just try and see how it comes out. That doesn't work, let's regroup, let's redo it again, and keep trying, right? That's where you see the success of certain products actually not really hitting their peak until a V3, for example, as opposed to right out of the gate being the first thing that you release is going to be awesome and everybody's going to love it, right? There's some iterations that have to happen in that process. So as part of the understanding the big picture, one of the things you need to do is understand who is your customers, right? What is it that we need to do as part of this solution? Why do we want to do it? Why? When is also an interesting one, right? When do we need to actually have this project done? And where? So it might be that you have this great idea, but it turns out that it takes so long to deliver it that it might be obsolete by the time the market ends up getting it. So you need to actually figure out how you're going to chunk and develop this software so that it can be incrementally adding value to your customers, and in the process you're learning from that and getting smarter. That's some of the examples that we follow, like Skype does this really great, right, where they end up going, and every quarter they have a sprint. And as they go through each sprint, they keep learning. If a market situation changes, they adapt. They throw away what they were going to do, and they address the issues that the market needs to do, right? And this is something really important that is part of that sort of program management role. When you draw the box and tell your story, you really want to keep into or take into account a lot of different pieces. You want to understand what your key customer scenarios are. So many times what happens is that somebody comes to you and says, oh, I got this great product that we're going to be using, right? Whether it might be some virtual reality set of goggles or things like that, and then they go, so that's awesome, that is really cool tech. What are you going to use it for? I don't know. It's just really cool, so why don't we just build it? So you need to understand what the real value is. And in doing that, and in order to do that, you need to understand what the market trends are. Are we getting in there because everybody else is doing it? Is everybody else doing it for the right reasons? How is this just going to be something that everybody's going to forget after a while, right? Or is this something that really is going to stick into the market? Now, as part of that, you might do some customer studies. Like when we were doing the browser, and now it's going to be the third time we're doing the browser in the last 2-3 years. One of the things that we're doing is that we're understanding how do people use the browser. What are the important things? What are the things that Chrome does very well? What are the sticky parts of that? And what are the things that we do really well, and what are the things that people don't like about what we do? Which one is the things that we care to promote as we go forward, right? So all of those things are really important for you to understand, and in some cases, you might end up doing surveys to gather some of that information. You might meet with customers, whether they're in the enterprise, or you might just go to the mall and do some surveys, right? It varies. And after you know that, you start trying to figure out, okay, so who are the partners that I'm going to be able to validate this concept with? Who am I going to be able to roll this out? So this is what makes it real. Like we were doing some work to be able to allow Netflix to play in the browser without the need of plugins. And Netflix was totally instrumental in this work that we were doing. There were about 3 technologies that we were going to implement. And without Netflix, none of this would have been real, because we would have been building technology for the sake of building it, and we wouldn't have understood why is it that we needed to do different pieces, right? So as we went through it, we understood some of the limitations, some of the advantages of actually having the technology in box, in the browser, as opposed to having to install a plugin, which many people give up before you ever actually even get going, right? And it was really important to understand and have that sort of North Star that you can always go to and say, we're about to cut this feature. Is it really important? Oh, okay, turns out it is. Okay, great. It will enable your business. after that, also, you need to make sure that you understand the scenarios that those partners want to really deliver on. Once you do that, you really have to set the direction. And that really talks about you need to network. You need to leverage skills and knowledge, gather all these technical details, because most likely the people in your team are going to have a lot of experience, right? You're going to know a lot of different people in different teams, and even the people in your team who have some very specific ideas about how to solve the problem. You want to leverage the skill sets. You want to get the detailed technical issues that you're trying to solve. And as you go and start to put it all together, it might take you some time to even have to go and prototype it. And as you prototype it, you go ahead and get an idea of how people might use your product, right? Like I did once a prototype for a no Chrome browser. And by that, I mean no UI browser, not Chrome. So when I was doing that and we actually put that in front of customers that we were testing it, they got all confused because they didn't know how to go back. And they were looking for the back button, and it was not there on purpose, right? And we were trying to figure out how much UI do you really need in order to navigate, right? And some of these things are things that until you prototype, you know. Otherwise, you go ahead and make wrong assumptions about the product. You get everybody going, and then you find out, oh, shoot, 3 months later, no, wrong choice, right? So that's one of the advantages of prototyping. Where the art comes in is that many of these problems are very ambiguous. And as they are ambiguous, that really by definition means that you don't really know how to approach them. There's so many different ways you can go about it. So what you want to do is you want to formulate a hypothesis. You want to be able to do that with the support of your team, some data that backs that hypothesis, not just guessing. I was going to say something else, but it's not proper. So anyways, so just not guessing, right? And then after you know that, what you want to do is be able to test it out, right? You try to draw that box, tell that story, and see if through the communication it actually works. And in this path, what you really have is a series of cadences that you're going to be going through. You put this high-level design, which is your responsibility. You work with your dev team to actually identify the detailed level design that they're going to do, which by them knowing the actual specifics of the component that they're developing, they will know what interfaces they need to implement, what inheritance they need to actually do, what is the best storage mechanism that they can leverage. Where from your perspective, all you care is that there's a storage mechanism that you can rely on to store the information that people use, right? And then with quality, you actually work on understanding that all these pieces are going to really come together, and also that these pieces can be tracked and measured. Because what's really important here is that over time, you want to understand how to iterate the system. And you want to have enough information from the user community to be able to understand how to iterate it, right? Then, when you get it from design, you want to go, obviously, to ship it. And in order to do that, you need to stay on top of all the aspects of the feature. You are the one that's sort of the holder of the message, the holder of the flame, right? You're the one that understand how all these pieces come together, and you need to keep reminding people, because at times when you start going really deep into this particular algorithm that is going to help me to sort things very, very quickly, I lose track that, oh, am I taking into account all the pieces that I need to sort? Am I getting a system that is flexible enough so that I can sort by last name, first name, and address? Oops, I forgot one. That's a problem, right? Because then your customer scenario is not met. You need to drive the schedule. You have to drive the logistics. Adjust the problems. If there's a problem that is going to now take 3 months to be solved instead of 1 month, how do we go around? How do we come up with a workaround that maybe is not as beautiful, but is still workable within the time frame that we have? And how do we postpone some functionality that we can add on at a later time, right? Then you want to go ahead and design for the next milestone, because chances are that as you are building it, right, we need to figure out where we're going to go next. And you need to be able to understand and help provide that continuity to your team by assessing the data that is being gathered, by understanding the customer reactions and all of those. And that is really a big communication challenge. So you have to go ahead and be involved. So if you look at the sort of overall PM skills, and this is my last slide, right? You're looking for somebody who's a leader. And by a leader, I don't mean somebody that's going to tell you what to do. It's really somebody that's just going to have this energy that is going to be able to rally the troops and get them going into the same direction. And more than none is really somebody who's good at dealing with multiple conflicts, multiple inputs, and be able to create this environment in which, hey, I gather all this data, understand the different points of views. Okay, let's go ahead and pick the one that best fits our team and our style, as many of you have said here already. And you want to drive to accomplish that goal. You want to walk in the customer's shoes. You want to be able to use the product that you are actually saying. If the product that you're developing is a set of APIs, guess what? You need to code with those APIs to see if they're good or not. If the product that you are developing is an email client, you need to use your email client to see if it's any good, right? Understand the competition. You need to have the ability to multitask because all these things need to happen in real time. And that's pretty much it. Any questions?
Questions?
Yeah, we've got a question.
Yep.
So coming out of college, I'm guessing you probably don't put someone in a project manager position. How would you actually go about getting that? Do you start out as a dev and then work your way up, or how would you actually become a project manager?
So at times you actually have different people who actually come in from college directly into program management. Some of those people normally go through the internship process because it gives us a chance to actually mold those people as they come in right at, as they're still in college. And I think even in the role as a program manager doing an internship, we would expect you to release a product which in many cases says, what is the feature that you're building? Does that feature has an API? Build a product on top of that and show us that you understand what you're delivering.
Right, so just to be clear, the job is program manager, not project manager. And it is an entry-level job. It's just another technical job at Microsoft. So we certainly hire PMs right out of college, but it's not, the word manager is probably an unfortunate choice made, 32 years ago or something, because it's not a management job. You're not.
Right. Actually, it is program management.
Yeah, you're managing the program or something.
Exactly.
Certainly, there's fewer PMs than engineers just overall, but
right.
We hire a bunch of
The ratio is 1 PM to 3 to 5 engineers.
All right. Yep. And I think also what you see is that people that end up joining the development as a software engineer, right, at times end up moving into the program management role, right? And even people in the quality org too, in the quality as a software engineer. So it varies.
A crisp way to kind of help you guys understand a little bit why you do dev or why you do program management. So a software engineer codes 100% of the time. If you are the kind of persons that you don't think you like to sit at a desk and just write code, and yeah, right. They write what we design. No, so if you have good people skill, you like to talk to people, and also want to remain very technical, program management gives you a good balance of those activities. So I'd like to move on because we're short on time. David?
I'm going next. Hi guys, my name's Dave Witt. How many mechanical engineers are in the room?
We still have 3 or 4.
3 or 4. Excellent. So Josh Grant and I are going to talk a little bit about mechanical engineering. I'm going to start off very general. He's going to go into kind of what happens in day-to-day life of a mechanical engineer. And we're going to talk a little bit, I'm going to start just talking about it much more generally. Mechanical engineering is a huge field. It crosses the gambit of just about everything from stuff that you see to don't see, stuff you touch, to stuff that is behind what you touch. Some of the different things that we work with are we create rockets, we build cars, we build consumer products, we build paper clips and power plants. All those are great fields for mechanical engineers to work in. I have no idea what Sterling code is and why it's unsafe, though. None at all. That's probably something I need to learn, apparently. I have no clue.
Did you have some slides you wanted us to see?
No slides.
No slides.
Yeah,
Okay,
mechanical engineers, we're lazier than that, so.
Shoot from the hip here.
Yeah, we tend to not be quite as detail oriented at times. I want to go over some of the types of mechanical engineering jobs. A lot of people when you're in college, you're really exposed to development. I'm going to design something. I'm going to create something new. That is one type of mechanical engineering job. There are a lot of mechanical engineering jobs. Reliability, if you like to break things, that's a great job for you. If you're really good at breaking things, you really should think about being a reliability engineer. Their job, different from the development guy, is they're going to work closely with the development guy and say, hey, you know what, that's going to break if you do this. And if you make that too small, it's going to fail. Or it's going to fail after 2 years, or it's going to vibrate itself apart. So those are the types of things a good reliability engineer is considering. There's quality jobs as mechanical engineers. You're trying to ensure that the manufacturing equipment that's making the product or the product is set up correctly. If you're a mechanic or a manufacturing engineer or quality engineer at Boeing, for example, you're going to be out messing with the 777 when they're custom fitting all the doors to it. All the doors are different on a big jet. So you have to have someone on the ground with every single jet making sure all the doors fit in it. It's not what you think about when you think about high volume consumer products, but it is what you think about when you think about a large jet. So quality, reliability, there's safety engineers is a whole other field of mechanical engineering. Making sure that people don't end up killing themselves is very important on job sites and at factories. Manufacturing, research, that's another huge area of mechanical engineering. Then there's all kinds of specialties. Any course or class that you have right now can also be a specialty in mechanical engineering. If you're looking at, if you really enjoyed your finite element analysis course and you got on that computer and said, this is awesome, it's a great combination of mechanical engineering and software meshed together. Get that mesh, haha. That's something you might want to specialize in. That takes people years to get very good at, and it's something that's worth a lot of money. Actually, I'm hiring an FEA engineer. Tooling engineers is another area. That's somebody who works with the plastic molding machines that make half the parts that are in anything that you deal with. Those machines are the size of this conference room, a lot of them. They're big machines, and they make lots of parts that are from tiny parts to big parts. The dashboard of your car down to the little parts in your cell phone. I think you guys can. All right, good. You can see me. All right. And those giant machines require tooling engineers that are mechanical engineering background to design them and make sure they're set up right to produce good parts. I wanted to bring those different types of jobs to your attention because when you're looking for a job in mechanical engineering, those are all great jobs. And you need to think about those and be willing to apply for those. You're going to learn a ton of information in any one of those fields. They all are related to each other, so that if there's something you really have a passion for and want to do, but perhaps there's not a job in that field or it's not in the area that you want to live, and there's something close, take it. Get some experience under your belt. Find out who is in that job that you want to do. That's what's going to help your career. So I want to start off general like that. Now let's talk about Microsoft. Microsoft's a big company. You've heard a lot about software. There's all kinds of software made here. There's actually all kinds of hardware made here. Yeah, mouse. Mice and keyboard. That's the boring stuff. There's Surface. There is the HoloLens. The Xbox is played with an Xbox.
Kinect.
The Kinect is a huge mechanical engineering feat in multiple areas.
Yep.
There's a lot of mechanisms in there that actually make the camera align and focus. There's optical engineers, which is another specialty of mechanical engineering, that have to handle making the lenses move in and out in order to make them focus. And then they also have a laser that they need to focus on the person, scan them properly, all that stuff, all a whole ton of mechanical engineering. We have our band, the Microsoft Fitness Band, servers and data centers. We have a lot of server and data center engineers here. There's a lot of activity in that field. If you look at a good data center, I'm wearing a Fitbit, not the band, so I wasn't going to show that off. The data centers, if you think about a data center, they are huge buildings full of all kinds of air conditioning and electrical power. The power lines are so big into those, they're about this big around. And if you're familiar with electrical engineering, it's easy to accidentally weld things together, like if you're messing with the leads on your car. Well, not a data center, because those lines will clear any fault that comes across them on their own. So it'll melt a wrench if you drop it on it. But huge amount of mechanical engineering in keeping those data centers cool, keeping them safe, keeping vibrations out so the disk drives can find the data that someone's looking for quickly. Those are all different areas of mechanical engineering that's here at Microsoft. So there's lots of opportunities here. Research is just one of them. In the research group, they're doing things that are 10, 20 years out. Three-dimensional viewing without glasses, all kinds of cool experiments and ways to trick your body into thinking something else is happening. That's potentially a future if we look at the HoloLens. Am I saying that right? That's a great example of how to make you think that you're seeing one thing, but that's actually not what's really in front of you. So it's some neat things like that. What else do I want to talk about? Reliability, breaking things, manufacturing engineering. In that field, there's lots of aspects of that. If you like working with how people's hands work or their arms or safety, ergonomics is a big field in the area of manufacturing, especially when you're dealing with factory floors that have a lot of people working on them. There's a lot of human factors involved in that. Same is true of if you're working on the inside of a car, putting the blinkers in the place where your hands can reach. There's all kinds of areas in manufacturing where you get to study those things and determine what's going to be the best design. It sort of feeds into the PM role that was being talked about earlier, setting up requirements for the development team. So the manufacturing team's going to come in and say, we need these kinds of ergonomics. You've made that too hard to assemble, or you've made that take too long to put together. Those are all different things manufacturing engineers are good at figuring solutions for and identifying problems as well. So that's just a little bit about mechanical engineering in general. I'm going to let Josh talk about what someone does day to day.
Sure. So I specifically work as, I guess would be the first category that Dave talked about, development engineer. So I have a couple kind of basic areas that you might touch in a day-to-day life, and I counted. I think I have 5 here, and I counted them up for how many I did today. I did 4 of the 5, so pretty varied.
Good.
Yeah, that's pretty good. The only thing I didn't do is go to China, which is kind of my 5th one. So that's later though, later this month. So I just wanted to start by talking about kind of some of the design principles of being an engineer. And obviously, every engineering job is going to be a little bit different, but this is for me here, and I think for a lot of the engineers I work with, this is pretty typical. So our first kind of design principle is quality and function always comes first. That's something that we never want to compromise on, and a lot of work goes into making sure that we are presenting the user with the right experience, and that when they are using the device, they're really experiencing it in the best way. After that, we look at cost and schedule, and those two things tend to trade off. You can spend more if you want it faster, and if you want to spend a little less, sometimes it takes a little longer. So that's kind of like the guiding principles that we use here. And now I'll talk about some of the things that we do on a day-to-day basis. So sometimes that typically starts out with kind of designing a part, which would be kind of using your computer. It usually starts in the computer. You do some type of CAD design, use that CAD program to make sure the assembly all fits together. You can do tolerance analysis to figure out how do I need to spec this, or where am I going to run into problems when I actually assemble it. And then you can do FDA, which we thankfully have. It's not my strong suit, but thankfully we have some people that specialize in that and that can help us do that. I can do a little bit, but it's definitely not my specialty. So I did that this morning. I designed the part. Then I went to we have a huge model shop where we can basically make everything. I mean, we have CNC lathes, CNC mills, water jets, laser cutters, 3D printers. So I actually went there this morning and I made some parts to actually get my hands on them and see if what I had made was going to work for what I needed to do. So we made some mock-ups. That's important for several reasons. One, you want to make sure everything fits, but 2, we want to make sure that the user experience is right. So if there's something in particular that we want to look at, for example, Dave has this pen right here. As he writes on the screen, we want to make sure that there's just enough friction that it feels good, maybe not too slick, but not too sticky either. So kind of working on something like that and figuring out exactly what the user needs is an important part, and that's really where testing and mock-ups come in, because it's something that's really hard to model on a computer, like using computer analysis to figure out. So you really need a physical model to do that, and so that's kind of one thing we use the prototyping for. Another area that's pretty big is the logistics, so that with making sure all the drawings are correct, that those drawings are released to the supplier, to the factory, making sure our BOM is correct, which our BOM is the bill of materials. So it's basically every part that we build in our product has to be specifically accounted for, and we have to know like exactly where it is, who's making it, when's it going to get there, are we going to have it in time to use, and that kind of stuff. And then working with the suppliers and the people who actually make the parts to make sure that we're going to get them on time. That's a pretty big deal, and we run into problems with that a lot. But it's always fun trying to figure them out. And then the fourth thing we do is working with factories. So our factories are in China. We travel there too much, but it's fun to travel. And so we have to help them figure out issues. Sometimes the issues are our fault. Sometimes they're not our fault. Sometimes the product design was poor, which I hate to say because that usually means it's my fault. But sometimes the design the part wasn't designed properly. So we have to go and figure out how to fix that. Or sometimes maybe it's a process issue, and so we have to kind of help them work through that and figure out if there's a better way to design the process that can help them make better parts. And the last thing comes down to meetings and communication. Communication is a huge deal, whether it's here in Redmond or whether it's with China. I think communicating with China is especially difficult just because there's a language barrier and they're so far and they're not face to face. You can't just walk up to their desk and say, "Hey, what's going on?" So communicating through meetings, conference calls, email, and even those days back when you were instant messaging on AOL Instant Messenger come in handy because we instant message all the time. So you may have never thought Yahoo Messenger would come in handy, but we actually use Link here, which is the Office version of kind of instant messenger. But those are all big things that we do on a day-to-day basis.
Question? Oh, we have a couple questions coming.
You have a question.
Hi. So I'm a sophomore mechanical engineer.
Can you speak up, please?
Yeah. I am a sophomore mechanical engineer here. I've had a bit of experience so far. I've done 2 internships, and I have a bit of experience in rapid prototyping. My question is, what do I do from here if I wanted to get a job in mechanical engineering at Microsoft?
All right, so you're already starting off on the right foot. Internships are a huge help, even if they're not here. Part of the reason for that is just having good grades, which is important as well, certainly for here at Microsoft. But you also need to show a track record of having been able to have responsibility. Internships and jobs as well are great ways of showing responsibility. If you have community service, that's another method of showing responsibility. The idea is that you can communicate to me or another hiring manager that you have the talent and the skills to follow through and complete something, and that you have the ability to handle different issues that are going to be thrown at you. You're in a job environment or an internship environment, you're given tasks, and you have to complete them. And that's kind of what a job is. We're all given problems to solve. That's why we're engineers. And we go solve them. Obviously, we want the best problem solvers that we can get. So that's what we're looking for as hiring folks. So for you at your level right now, staying focused, learn those basics. One thing, I'll put a 6th thing on Josh's list, free body diagrams. When you learn those in mechanical engineering, I use them, I don't know, every other day almost, it seems. They still come up after doing this for 20-some years. Getting on the whiteboard, being able to come up with ideas, come up with the physics behind what's happening is important. There's a lot of those types of activities. So learn your fundamentals. It's huge. The fundamentals are a big part of the interview process here as a mechanical engineer. We're going to ask you about stress-strain curves. We're going to ask you to draw them and tell me what the different sections are. If you can't do that, I don't believe that you're going to be a good mechanical engineer. So getting those fundamentals down, staying focused on that, and then also making sure that you apply for the internship when that next round comes up. It's August, is that?
Yeah. So are you currently a sophomore or what?
Yes, I'm a sophomore this year.
Okay. So fall apply, and you should be in the pipeline.
So that's your next step for being an intern here. I would also recommend apply as an intern for lots of places, and because you want lots of choices, lots of options. The internship program here, it is highly competitive. That's a good thing. And even if you have other internship offers or chances to interview, take each one of those chances to interview. It's great practice. Throughout your entire career, you're going to be interviewing for a job. Even if you already have the job, you're sometimes always re-interviewing for the same job. Every opportunity that you have to get that practice is going to be essential for you and make you a better person for the next interview that you have. Any other questions? Or did I get that? Yeah, go ahead.
Out of curiosity, what CAD package do you guys use at Microsoft?
Pro Engineer.
Creo too, technically, but.
Okay, I think we're done with the questions for this one.
Sure. Any more questions?
No, I don't think we have any more questions for this one.
So, Peter, you want to come with?
Yeah.
We only have a bit more time than mechanical engineers.
Yeah, I know. I believe you.
We have work for you then.
I just want to say one thing before you start. I just, I've done this a few times with the college. It's a real big deal that I can get real engineers here in EE to talk about this because the college has more engineers than computer science programs. So for that reason, go ahead.
Hi everyone, my name is Peter Jasinski. I'm a design verification engineer with the Surface team. We'll get into exactly what that means in a second, but I'm here to talk about electrical engineering. My degree in college is as an electrical engineer. I just work as what we call a DVE, which is kind of the equivalent of he's going to tell you. Oh, okay. It's essentially a hardware tester. I test everything except for really reliability on a hardware product. Let's see if that. Oh, good.
Down arrow.
Down arrow.
Yeah.
So the first question is, where are electrical engineers at Microsoft? This kind of piggybacks with what Dave was talking about. Microsoft is, the first thing you think of is we're a software company.
Yep.
When I told all my friends at school that I was going to be work at Microsoft, they were kind of like, well, what are you going to do? Like, you're a EE, you don't write software. This is where EEs are at Microsoft. One of the big ones is Xbox. There's tons of electronics, and actually every one of these things, they're basically electronics with a mechanical shell and some software, but that's my bias to you. Xbox is one of our huge products. We do a lot of PC hardware, so mice, keyboards, and webcams. VLSI for you EEs, very large scale integration chips. A lot of the chips in the Xbox are actually homemade. We have groups down in California which design those chips from the ground up. So if that's something you're interested in, Microsoft does that as well. Not very well known, but we do design chips. The Microsoft Band is one of our newer products. The newest one is the HoloLens, which is really cool stuff. If you haven't seen that, definitely take a look at it. Same thing with the Perceptive Pixel or Surface Hub. This was just announced a few weeks ago. This is huge into the display. The display is just this insanely gorgeous, really precise display. So we'll touch into where electrical engineers get into that, but it's one of these newer products that hasn't been released yet. Phones, that's another big thing that we bought, the Nokia Lumia phone line, and it's something that a ton of electrical engineers need to work on. And then my favorite, of course, is the Surface. I like to call that out individually. But, of course, all of those that's where you would be as an electrical engineer at Microsoft. Again, piggybacking up what Dave and I spoke before this meeting, so I'm going to kind of follow what he talked about. Different types of electrical engineers at Microsoft. When I started, my offer was as a DVE. I had no clue what that was. I thought all electrical engineers made schematics, designed products, and that's really not the case. So we'll step through. The first one is electrical design. This is what you kind of think about when you are becoming an electrical engineer. People who are doing product design, so making schematics for the mice, making schematics for keyboards, doing the motherboard design and layout. RF engineers, so people who understand frequencies and over-the-air Wi-Fi, GPS, LTE, and how antennas work. VLSI, I spoke about this a bit, is the silicon chip design. We have component engineers, people who focus specifically on designing displays or speakers or sensors, and then people that own specific subsystems. So within the Surface, we'd have an electrical engineer who owns all of the sensors, and they focus on that, and they're experts in how sensors work and how sensors can be integrated together. These are all very specialized areas, but it kind of shows that if you're just doing pure EE development, you can still specialize in one of very many areas. The next one is system engineering. This is kind of a step, I call it a step up from electrical engineering. A system engineer is someone who kind of pulls in together all different aspects of the electrical side of a project and makes sure things are architected correctly, make sure that the firmware and the electronics and the software are all working together. Most of these people have EE backgrounds as well. Design verification is my job. As a design verification engineer, I'm in charge of testing the product from its the electronics, the firmware, and the software interaction to make sure that the product that we give the customer has no bugs. Of course, we're never going to get at that point, but it's my job to find all the bugs find all of the bugs in the time frame that allows our product team to fix them before we ship the product. Because what we want to give the consumer is a perfect product. Firmware development. Within all of our embedded chips, there is firmware. A lot of our firmware engineers actually do have a EE background. It's kind of half and half between software backgrounds and EE backgrounds, but it's something that kind of splits the difference between software and hardware. Compliance and agency. This is one that I had never heard of before coming here. If you guys look at any product, any electrical product that you have, it's going to have some sort of, let's see if I can find it on here, some sort of marking that says FCC. That means that we are compliant with a list of regulations provided by the government. This is in terms of, can you withstand ESD strikes? Can you withstand RF interference? And these engineers are the ones that design the test plans and make sure that we can do that. You actually cannot sell a product in the U.S. without getting that mark. So it's very important to have these people watching our backs. GFX is designed for excellence. This is big in like motherboards where you're doing huge PCB layouts. What they'll say is they'll look over your design and make sure that you are putting resistors in places that you can put them and that you can actually build what you're designing. Especially with huge PCBAs and lots of components, it gets really complicated with design techniques, and it's their job to make sure that it's actually possible to build that. Manufacturing tests. This is kind of my counterpart in the manufacturing world. Every single piece of hardware that we build gets tested at several points on the assembly line, and we have to make sure that once the design is good, that we can build it correctly. So manufacturing test engineers own that side of the test process, and there's a lot of EEs both that own the testing and own the equipment that runs that testing. It's all homegrown equipment. And finally, project management. Like we talked about, there's program managers. Or maybe I have the word wrong. There's program managers for software. There's one for hardware as well. So a PM in hardware would kind of own a keyboard and make sure the keyboard can get to market. Especially for some of the subsystems in our larger products, like a motherboard, that PM has to have a lot of EE background because they are building a system that is almost purely electrical engineering. So we see a lot of PMs have a EE background and are working in pretty serious EE projects. And then research. We have a lot of research arms at Microsoft, and a lot of them need electrical engineers. So this is something that's kind of more towards further out products and doing some really cool stuff. But that's definitely an opportunity as well. I wanted to step through I call it the daily tasks of two of these, kind of what we do on a daily basis. I spoke with the EE on my program who sits across the hall to see what he does on a daily basis, and I'll just step through some of these. So as an electrical engineer, you're doing a lot of schematics. You own the schematic for a design, so you have to design that. Component selection is actually pretty big. Especially when you're talking about making millions of things. You can't just buy them off DigiKey anymore. You've got to actually make sure that the people making your components can supply them. PCBA layout, kind of tied in with schematics, but it's something that you don't really work with in school a lot. You're doing a lot of breadboarding, but when you go to consumer electronics, you have to understand how PCBAs are laid out, and it's something that you learn on the job a lot of different rules. It's definitely, if you ever have the opportunity to lay out a PCB in school, I definitely recommend taking that. Board bring up is kind of after you lay out a PCB and get them built. We have to make sure that it works. Before we give it to the firmware engineer, before we give it to the software guys or the mechanical guys, we got to make sure that it was built correctly. Because there have been times when we build a PCBA and it just doesn't work, and you don't want to give that to people. Architecture planning is kind of at the start of the program. You're kind of making sure that everything fits, making sure that the chip that you're putting into your process onto your board can actually accomplish everything you want, making sure the accelerometer that you're choosing has the capabilities. Spec writing is huge. It's something that you really never do in school, but when you're building a project, you have to document how it works, because this is everyone reads the specs because they want to understand how your project is actually working. So having a good spec is a huge part of that, and it helps in the long run.
So question.
Mm-hmm.
So this list is not ordered, right? You know,
I kind of ordered it in terms of things that you would think that they would do. A college student might think that they would do, down to things that they would.
So my question is, do you would write specs before you start doing?
No, it's not ordered in terms of time. No, not in terms of time. Yeah, you should write your specs at the start. Okay. No, yeah. Building planning, like
there are different specs. There's specs at the start, which are high level, and then when you're done.
So I was just reading a spec today that kind of talked about our next build, and it had like really nitty gritty. We changed R47 from 100 kilo ohms to 10 kilo ohms because of this reason. But it's all documented, which makes my job really easy. You got to plan for builds, like Josh was saying. We go to China to build stuff. You got to plan for that because you got a 2-week time to build 1,000 units, and you want to get it right. And then, as Josh was also saying, with communication, team alignment. Doubles talk with the PMs, with the mechanical guys, with the firmware team, DVE, your sourcing, the people who are actually getting the components from suppliers all the time, making sure that the team is in constant alignment. My job as a DVE is a bit different. Again, I have a double background, so I spend most of my time around circuit boards, around firmware. The biggest part of my job is test plan development, which is actually deciding how I'm going to test a product. Am I going to test signal integrity on these lines and the latency between pressing a key and having it reported on USB to the force to fire on a touchpad? These are all the things I test. But I have to actually create a plan and present that plan to people to give them the confidence that we're testing the hell out of this product. And then executing those tests is obviously the other big part of my job. I have to create tools that allow us to test these products and fixtures that allow us to test it. If you look at a keyboard, if you want to test the force that it takes to press a key, how do you do that? That's a huge question. Actually designing your tests and making them so that you can run them is a huge part of my job. The EE writes the specs. I review them to make sure that they're calling out everything that we need to do. We have great bug tracking systems. So anytime I find a problem with a product, I log a bug. Consequentially, a lot of my time is spent tracking those bugs to make sure they're getting fixed on time, they're assigned to the right people so that they can get resolved. When I also found a bug, I do a lot of debugging and root cause analysis to figure out where the specific issue is. Again, I also plan for builds, and then I spend a lot of my time communicating. See, it's a bit different. I talk with my PM, the mechanical team, firmware and software, my EE. One of the most fun parts of my job is working with the user experience, research, and industrial design teams. These are the people that are kind of talking about how the product is going to be used by the user and designing different aspects of the product. I love that because it's something that's much more subjective, but it's fun to get to work with them on the same day you get to work with an electrical engineer that's dealing with very objective results. And then I work with a ton of other test teams. Like, I don't test the RF spectrum. I don't test any antennas. We have a team that does that separately. So working with them to make sure we're testing all aspects of the project. And then I wanted to finish up with talking about things to know about kind of electrical engineering and what might kind of give some pointers of going forward. First thing is all about problem solving. That's why we're engineers. So kind of when you're thinking about becoming a EE at Microsoft, this is what you're going to be asked. You're going to be asked to solve problems. Someone's going to say, we have to create this circuit board that fits in this super small product, and it has to have all these components. And that's a problem, and you have to figure out how to solve that. So when they're doing resumes, interviews, or even at an internship, remember that it always comes back to what's the problem you're trying to solve, and what are the creative ways to solve that problem? Because that's what Microsoft is looking for in kind of all of these roles, but also within electrical engineering? How do you solve them kind of the best way? Thinking about the customer is huge. This is something that's really fun about, I think, Microsoft in general, but Surface, where I get to work, we're kind of told to make perfect products, which is a lot of fun because it's good to strive for perfection. And this is something that I think that I never did in college, but I wish someone had told me, is that when I'm breadboarding out some project in the lab, I kind of had these requirements that your professor gave you, and you did those requirements, and that was it. But I never thought about ease of use or reliability of the project that I'm making, or writing specs about it. So when you're doing these things, what's a great way to prepare for a professional job is thinking about the customer, whether it's your professor, whether it's someone who's using your project, and kind of plan for them. Think about it from their point of view and what can be done better. Learning about professional engineering. This goes back to like PCBA layout. It's not something you're really ever going to do in school, but if you have the opportunity to learn about kind of things that real-world engineers do, take that opportunity. One of my internships, I had the opportunity to lay out a PCBA, and I did it once, and it was probably done really poorly, but I learned a lot about that as well. So take any opportunity you have to talk with someone who has designed products, who has been in a ship cycle, to kind of learn from them what are the differences between breadboarding something on a lab bench and making something that 1 million people are going to use. And then just investigating your areas of interest is one thing. I find myself doing this a lot. I'll be in a meeting and someone will use some term that you don't know about. And
Starland.
Yeah.
Starland.
So as you're reading some article about new electronics in some magazine or online, and you see something that talks about, it's simple, but like a spy bus. I never worked with spy buses in school. Search it on Wikipedia and learn about it, and those are the things that are going to really stand out when you go to an interview. Mm-hmm. The interviewer asks about your knowledge of serial interfaces, and you say, "Oh, I know about SPI and I2C," and it's something else that kind of gives you that extra edge.
Cool. This is a great presentation.
Yeah, that was it for me.
Thank you. Now, questions. Questions is good.
Any questions? Yeah, we got a question.
We'll help you.
You probably can't see me, but
we will soon. Go ahead and speak.
Yeah. So my question is, I'm currently working on a job on campus, and I have to.
Can you speak louder, please?
Okay. I currently work at a job on campus, and I have to debug a number of electronic circuits and things like that. Mm-hmm. I'm just curious about what the most common tool that you use, besides a voltmeter and oscilloscope, is to find where a problem is.
Those two are definitely the most common tools I use. After that is probably interface sniffers. So a lot of the bugs that we find are like the microprocessor talking with the peripheral, or the microprocessor and a keyboard talking with a controller on the actual surface. So it's the interfaces that something's gone wrong on USB or I2C or SPI. So I've got a whole host of little what are they called? Little tools that I can put on a line we call it sniffing it, to actually see what's going on the bit level and the byte level. So I use those on a daily basis.
Thank you.
No problem.
This isn't electrical engineering related, but going back to the software, you mentioned, like, this is mostly curiosity, but you mentioned about working a lot with legacy code, especially for Internet Explorer. For something like Spartan, where you're kind of starting over sort of new, do you have a lot of, like, do you create a completely new code base, or do you kind of build on the core of IE, or how exactly do you build when you do a really new project like HoloLens or Spartan?
Well, Israel left, but you guys can talk about something similar.
Well, I don't know anything about Spartan, actually, honestly.
No, not Spartan, but something
in the press. But I mean, there's usually start with something. I don't know. The HoloLens I know even less about. But I mean, I have a Microsoft Band, and the Microsoft Health app, which is fairly small, was probably written from scratch. It's an app that runs on mobile devices. It doesn't really do that much, so that was probably somebody sat down and started out with a main, like just a empty application. But we've been working on new versions of Office, and they look new on the outside, but there's a lot of reused code from older versions inside. So I suspect that Spartan, which I guess is a new browser we're supposed to be working on.
I don't know how much we should talk about.
If there is such a thing, honestly, I actually don't know anything about it. I expect each new version of Internet Explorer probably starts the basis of a lot of existing code somewhere. There's a lot in a browser, and I doubt somebody sat down and just wrote it from scratch. It's, it'd be very hard to do.
Okay, go ahead, Eric.
I was going to say, me and Bernard actually worked on something that kind of started new, Azure, right?
Yeah.
But the problem is, even if something's brand new, it's not very long before it's legacy. So legacy doesn't mean it has to be 10 years old or 20 years old, right? Like in Azure, you might start with a small group of people, but as you're ramping up, you're hiring more people in, and when those people come in, the code that's already there is legacy to them, right? So it's almost guaranteed, from your point of view, that code, even if it was only written a day ago, it's a legacy to you, right?
Right. The other thing is, a lot of times you'll start with something and then just keep replacing parts of it, replacing subsystems and stuff, and eventually, I guess you have new code everywhere, but you never, you were still dealing with legacy code while you were upgrading it in pieces.
As your own repertoire of what you have written grows over time, and you go start on some new project somewhere, you'll say, hey, I wrote something like this, 2 years ago. This component, this particular tool, this way of doing some processing. You gotta go get that code, and you may tweak it a little bit. So any of the projects that we have here that start from brand new, there probably is a lot of stuff that's happening. There's layers of that application that are not new. They are baked, very common libraries that are being used over again. But then there's a whole lot of new stuff that gets added to it as well. So
I can say something about the Office. So the most well-known software that Microsoft produces Office, right? And it used to exist in Windows and then NT and then 8. But we have, in this release that we are going to ship sometime this year, what we call the immersive application. So that actually has quite a bit of core functionality that we reuse, right? Because if we were to rewrite every line, it would take us forever. But the things that are different is writing it on the new Windows SDK, which you guys can get as preview. So the whole immersive app, when you open it up, it takes over the whole screen. So those are the new things that we do. So that's another example. Follow-on question?
Well, I'd like to contrast that with hardware a little bit. So with software, I don't have any experience with software, so I'm just going off what you said. It sounds like there's a lot of pieces that might get reused, whereas in hardware, basically everything you do is kind of custom, and even in a whole product cycle, you could have parts that look exactly the same that are actually made on totally different tools. You might have 5 different tools for the same part in a product cycle. So that's kind of a cool thing I think about hardware. It's kind of everything you do is kind of custom and kind of starts from scratch in a sense.
And just to give the doubly perspective on this, I've worked a couple of products that kind of lead onto each other, different generations of the same, like Type Cover 1 and Type Cover 2. Those two, we didn't have this, but what we'd love to have from a doubly perspective is using the same exact PCB in each one, or minimal changes. So what I like to see as a test engineer is that we take someone that we've already proven has worked and just use the same thing. Because that means we've already solved all the bugs. Now all of the bugs. You're never going to have that, but from the test side, we like to see consistency between our programs.
Okay, makes sense.
Yeah.
Reuse.
Answer one question.
Any more questions?
One more. Let's see. 1 second. One more quick question for the electrical engineer. Have you ever been involved or do you know anyone that's involved in programming for some embedded electronics?
Embedded electronics.
Yeah, so with the firmware engineers, they're doing all sorts of embedded programming. So, like I said, I worked on Typecover 2. That was my first big program on the Surface, and in there we've got a little microprocessor that gets programmed, and that's kind of half of my job is making sure that that works. So we've got several teams in Surface, and I'm sure several more across the company that are firmware engineering teams. They're actually programming little microcontrollers, and some of them are, like I said, some of them are electrical backgrounds, some of them are software backgrounds, but it really does kind of hit the difference between those two. Did that answer your question?
Yeah, that's all I have.
Yeah.
You guys have time for one more?
Oh, keep it going.
Okay. So for the software stuff, a lot of what you've been talking about has been stuff with IE or Office. Like, and you were talking about the interviewing process earlier, and some of the questions you asked. Do you know what some of the differences are between what you look for in that end and what, say, like a 343i or Turn 10 would look for in some of their interviewing processes?
What's the last part? 340?
Gaming studios.
Oh, the gaming studios.
Yeah.
You guys want to take this question?
I suspect they'd be very similar. That might be more graphics-related questions.
Yeah, I think the only thing I've heard is that they do like to hire gamers. They're particularly interested. I mean, you don't necessarily get passionate customers of Office. I mean, maybe there's a few among the billions, but a lot of people don't come into Office, don't come in and say. Although we've interviewed people who said OneNote's my favorite application, and they got to go work on OneNote, and they were super excited. But people don't come and say, "Oh, I love making spreadsheets," that sort of thing. But I think the gaming studios like to hire hardcore gamers because they've got they want people who are very passionate about what they're producing. And
actually, that's a good point.
But technically, I don't think they're you're writing software to solve some problem, connecting API B to UI A.
I know of a couple of examples of people that were recruited because they were active on user groups. For example, Josh, you know Stephen Liu, right? Stephen was he was a college student, but he was very active writing software, free software. And the recruiter found him and say, "Come and interview." And he's working in Azure. And especially in the gaming, I'm not a gamer. I'm sure there is all this network games kind of forums where you can try to be active, put free stuff out there, you make a name for yourself. That's a good way. So I think, your generation is mostly about social. Throw a few games out there, put a Facebook behind it. You're good to go.
I think because a lot of games allow you to mod them. You can make design levels or whatever. And I think if you came in as a candidate and you could talk to somebody who worked on the other side who had been providing the platform, and you were a consumer of the platform, as a gamer, you could have a pretty good discussion about what you liked and what you didn't like, and that would make you a very interesting candidate. Especially if you came with the attitude of, "Hey, I think it could be a little better if I was working on it," which I think people do like to see that.
Right. More questions? Actually, I have a question to our hardware and engineers. How big is our Surface team, David? You have to take a guess. All the engineers, hardware side.
Mechanical or
the whole thing? Hardware, software. I mean, the Surface team.
We're over 900.
900, all disciplines.
All disciplines, over 900, and then I've been here almost 4 years, and when I joined, it was just over 200.
Hmm.
Give you an idea how fast just that organization has grown in just 4 years.
Okay, it's all under panels, basically.
Yes.
Okay, so that's and he doesn't own all hardware, right? Like HoloLens and all that is not there. Right?
Correct. He owns Surface.
Okay, this is just a Surface.
Yeah.
Xbox is some. Okay.
Even ELAP owns all the hardware.
900. That's good size. Yeah. Any other question before we wrap?
Yeah, I have one. How How useful is a graduate degree, such as a PhD or master's, in being hired at Microsoft?
Good question. Go ahead, you guys.
I can take that. It is useful. In the end, when we're looking at resumes and you're being compared against another resume, the more pieces of paper you have, the better opportunity that you have. So it doesn't mean that you have to have one. After a couple of years experience, it's probably not as critical that you have one. There's very few jobs where you have to have a master's. In fact, I'm not sure that I can think of any where we've said a master's is a requirement for a specific position. That said, when I'm comparing candidates, all else being equal, the guy who has an extra degree is going to get it. Same thing of the PE license. That's another example of having gone an extra mile, and you have an extra piece of paper that says you've done a lot and know your fundamentals very well. That's another method to gain an advantage over your competitor in the interview world. So it's not usually a requirement. I would also say that there are jobs that require a PhD. Those are highly specialized. If you want to be a material scientist, you probably need to have your PhD.
Or like an antenna designer.
Correct. An antenna designer, an RF engineer, those guys need to be doctorates. If you're going to be working on our display modules for the screens, the touch display panels are very high-end physicists who work on those. So you need to have your doctorate for that. So there are certain jobs that do require that advanced of a degree. However, for most of the mechanical engineering teams that we hire, a master's isn't required, although there are a lot of us that have them.
So in your experience, after you hire them, do you find that the graduate degree was helpful, or would it comes out in the wash if you have?
It's very personality dependent, and that's why practicing interviews is so important, because it comes out quickly in an interview whether you're the kind of highly driven person who's also highly competent at the same time. You can have those things individually as well. But if you have both those, highly driven, technically highly driven, to get things done, get things shipped, solve problems, those are characteristics that we're going to be looking for. If you have a master's degree, it certainly demonstrates a stick-with-it attitude. It demonstrates an ability to finish something, and you can get the same thing from other job experience. However, a master's does often give you some more technical skills at times, not typically required for what we're doing, but it does help, and I'd say that people with the master's often have a little bit more analytical skills if we're looking for that in the role. But
I can add a little bit from my experience, just to throw it out there. If I kind of added up mentally how many students, like, so Kurt said there are 50 EE and 100 some ME, so total 200 to 300 engineering students. When I graduated, the graduating class was 26. So and I went to grad school, and I found it really helpful. And the reason why I went back to how small my class was, I also thought that Walla Walla is a smaller school. You get a lot of value being a smaller school, but in some ways you don't get as much exposure when I went to grad school, because there's a PhD program. Just the breadth of research, right, that the different advisors have, it's really helpful. So for that, so I think David is right. It's not a requirement to get a first job, but it helps. And graduate schools also help you deal with ambiguity better, because you are not told how long to do it or when you have to get it done. In fact, you're never told that. I remember my advisor told me you have 6 years to graduate before we terminate your master's program. So don't ask me when you need to turn in this piece of work. So that's helpful. Any more?
I think in software it's similar. There's certain jobs that are very specialized. Most people have a PhD. That's some areas, if you study machine learning, big data sort of stuff, or search algorithms, that sort of stuff, or in gaming, if you were really knew a lot of algorithms, graphical algorithms, that sort of thing. That sort of thing. If you were really knew a lot of algorithms, graphical algorithms, that sort of thing. If you were really knew a lot of algorithms, graphical algorithms, that sort of thing. Or in gaming, if you were really knew a lot of algorithms, graphical algorithms, that sort of thing. you know, it could be quite useful and you would stand out, and it's more than you could learn in 2 years as a working at Microsoft. But a lot of jobs, as you said, you know, after a couple of years, after 5 years, it probably doesn't matter much. You've learned more on the job than you learned in school anyway. So, but certainly, if you want, security is another one. You know, if you went and studied certain areas for a couple of years and got a master's, you'd make yourself quite an attractive candidate to.
Yeah. Any more? Well, I think this is good. David, are you there? You want to wrap this up?
Yeah, you bet. Mr. Pham and friends of Microsoft, thank you so much. I think the information we got tonight was probably some of the richest, most specific information that we've gotten to students in a long time. So we appreciate your team, and we appreciate your time. Thank you.
Thank you. Good luck. All the best. Thanks, everybody. Hey, I'm going to stop the recording, and David, I'll get in